Okay, so here is one example of angle relationships. Example that isn't as easy as the previous video. And I'm going to use Greek letters this time to identify my angles instead of the 3-letter combination method. Okay, this red angle I'm going to call theta. That's usually what I start with. That's theta. Okay, this blue angle I'm gonna call gamma. That's a gamma symbol. And this purple angle I'll call lambda. Okay, so I just labeled these with names that are Greek letters. Okay, and you might see it makes the proof easier to write out because you don't have to figure out what the vertex is and stuff like that. Right? So let's go ahead and make some given statements out here. Okay, the first given statement that I can make from this drawing is that I'm going to use angle ACB is a straight angle. Right, because it's obvious that angle at C lies on line AB. Okay, and here C is the vertex. Now I did this in the 3-letter format just because that is like a good starting point, and it doesn't get too hard at this point yet, right? So this is given to me. Okay, now because that angle ACB, I can see that the measure of angle ACB equals 180 degrees because that's the definition of a straight angle. Okay, so I've established that this angle here is ACB, that angle is 180 degrees because it's a straight line. And by now that should be obvious, pretty easy. Okay, and because I named angle DCE gamma, I'm just going to call it gamma, right? So I'm going to say that gamma is a right angle. How do I know it's a right angle? Well, it's got this cool little symbol right here that indicates to me it's a right angle. Okay, that was given to me. You cannot assume that this is a right angle unless the little perpendicular square symbol is there. Okay, and so I can say that gamma, the measure of gamma equals 90 degrees. Right, which is pretty cool. A lot easier to write because this is the definition of a right angle. Okay, so far I've identified that this equals 90 degrees. All right, so now I'm going to make a relationship statement that's going to encompass everything here. Okay, my first relationship statement I'm going to say is that that angle ACB, my 180 degree one, equals that angle plus that angle plus that angle, known as theta plus gamma plus lambda, right? Equals theta plus gamma plus lambda. And why can I say that? Well, it's angle addition. Postulate. Okay, postulate. Right, so see how this is a little cleaner than this, right? Or this. You can't really see it real well. Hold on, like this or this. I like that a lot easier as long as you're using Greek letters and you identify those angles beforehand. Instead of calling angle ACD, you can call it angle gamma. Now, in word problems, when that's the case, you can just one-line those things, identify them, and I'll show you how to do that on a different video. Okay? And I also know, so now I know that angle, I'm trying to solve here for angle theta, lambda, angle lambda, the purple single, right? So I'm going to rearrange this equation and say that lambda is going to be equal to, okay, so if I bring this over, if I'm just going to bring these two over to this side, it changes the positive signs in front of these things to negative, right? So it's still going to be angle ACB minus theta and minus, whoops, supposed to be blue, minus gamma. And I can say that because of algebra. Clean up this a little bit here. Okay, and now I'm just going to go ahead and substitute in some values. So it's going to be equal to 180 degrees, which is the measure of ACB, minus 50 degrees, minus 90 degrees. And this is substitution. I substituted the names for their values. Okay, so now I'm just going to go ahead and do the rest here. And 180 minus 90 is 90. Okay, and then 90 minus 50 is 40 degrees. All right, so this angle theta equals 40 degrees. So it's 40 degrees. All right, and this should make sense. 40 plus 50 is 90, plus another 90 is 180 degrees. It's a straight line. Okay, so that's how you do that one. Let me pause to prepare my next one. All right, so here's another interesting one. I like this one a little bit. So it gives me two givens. It actually gives me three givens here. Can you figure out what the three givens are? All right, well, the first given is that angle ACB is a straight angle. It's given. So I can, because of that, I can say that angle ACB, the measure thereof, equals 180 degrees. So all this together equals 180 degrees. Okay, another thing that is given to me, and I'm going to start naming these angles in Greek letters. I'm going to name this one theta. I'm going to name angle ACE lambda. And I'll name angle ACD with a red as gamma. Okay, so though I name those things Greek letters because it's easier to write all that stuff down instead of writing down the three letter nomenclature for those angles. It just helps keep your brain from scrambling as much. Okay, so another thing that I can say is that gamma equals 40 degrees because that is given to me. Right, and then it gave to me that angle CE bisects angle ACD. Okay, so what does that mean? What does that tell me? Okay, so I can say a number of things, whatever way I want to go at it, right? So I'm going to say that angle gamma is congruent to angle lambda. Now, that's what bisects means. It means it takes angle ACD and splits it exactly in half. This angle lambda and that angle gamma have the same measure. okay? Because this is the definition of an angle bisector. Okay? So this angle and that angle are the same measure, and that angle is 40 degrees. All right. So I guess I'll put that down there. I'll say the measure, so gamma, because this is in Greek letters, I'm not going to put the little measure symbol, right? Equals, they're the same measurement because that is the definition of congruence. I guess I'll put the measure in there just so it's not as confusing, right? Small difference between congruence and equality. Measures are equal, angles are not, okay, because they occupy a different space on the plane, but the measures are the same. All right, so let me make this into an arrow just to clean my work up and make it consistent. All right, so how does that help me? Well, I'm gonna go ahead and let me go ahead and build a statement based upon this, right? I'm gonna say that angle ACB equals gamma, which I know. Sorry, that's theta plus gamma plus lambda. And that is because of angle addition. Angle addition postulate. Okay? So what? Well, if I know that these measures are the same, right, then I can say that instead of lambda and gamma, I'm just going to call this one gamma, right? They're the same measure, so they're the same angle, right? So if I'm going to do that up here, I substituted, lambda for gamma. I'm going to substitute it right here. Angle ACB equals theta plus gamma plus another gamma, or two gammas. I'll make a combination. I'll make other colors. I'm green. Two gammas. Okay, so it's two gammas because they're the same. That I was able to say because of substitution. Okay, I substituted one equivalent things for another, and then I did some algebra too. Okay, so now let me rearrange this and solve for 1 gamma, right? So I'm going to say that 2 gamma equals, the measure of angle ACB minus theta. And since I'm not trying to solve for 2 gammas, I'm trying to solve for 1 gamma. I'm going to do that gamma equals, I have to divide both sides by 2, angle ACB minus lambda theta all divided by 2. All right, and I'll go ahead and substitute 180 degrees. This was algebra. minus 40 degrees, all divided by 2. So I now can say that gamma equals 180 minus 40 is 120. I'm sorry, 140, excuse me. Divided by 2 is 70. So 70 degrees. So this is 70 degrees, this is 70 degrees, and that's 40 degrees. Add them all up, they equal 180 degrees. Okay, so that is how you write the proof and the solution out for this one. I hope that makes sense.